Welcome to this video on writing and solving equations. This is similar to what we were just doing previously. There's a couple of these I want to help you get started with so you can finish these out. The assignment wants you to read each scenario, write an equation for it, and then in this box over here, you're going to solve the equation. So these first four are pretty straightforward. Let's look at 5 and 6 down here. So let's look at number 5. We have Brody has $2 more than Trace. Together they have $26. How much money does each person have? So we've got two people going on here. We have Brody and we have Trace. Okay, now they're relating how much money Brody has based on what Trace has. The problem is we don't know how much money Trace has, so we're just going to say Trace has X amount of money because we don't know what it is. Brody has 2 more than whatever Trace has. So he has what Trace has, which is some value of X, plus $2 more. Okay, so here, this is what we call defining our variables. Just kind of help me understand what I'm talking about. Now, I know together they have $26. Remember, together is one of those addition words. So we're going to say Brody plus Trace equals $26. From here, you're going to combine like terms and solve, and you'll use this space over here for that. But I wanted to help you set up the equation. Let's try it again. 6 is very similar. It's Sarah bicycled 3 miles further than Megan, but we don't know how far Megan went. The sum of the distances they bicycled was 25 miles. So we have Sarah and we have Megan. Okay, Sarah bicycled 3 miles further than Megan. The problem is we don't know Megan, so we say Megan has some value. We don't know what it is. But Sarah is that same value, but 3 more. Okay, so we've taken the verbal expression and written it as algebraic expression. But we're going to turn it into an equation now that the sum of their distances, and we all know that sum means add them together. The sum of their distances is 25 miles. So I take Sarah plus Megan, and they equal 25 miles. And then you're going to go ahead and solve that equation to find out how far did each cyclist travel. Now, to determine how far each cyclist traveled, when you find the value of X, that's how far Megan went. You'll have to add 3 to it to find out how far Sarah went. So plug them back in to find the answers to the questions. All right, flip your paper over. Let's look at number 7. So we have the Blue Jays, and they won twice as many games as they lost. They played 96 games. Write an equation that will help you find how many games they won. Okay, so the two things that we're talking about here is winning and losing. We have winning and we have losing. And we want to know they won twice as many games as they lost, but we don't know how many they lost. So we say lost is X because we don't know what it is, but win is twice that amount. So that will be 2x, because twice means multiplied by 2. They played 96 games. So what they're saying is if you take your wins plus your losses, you're going to get a total of 96 games. You have like terms, combine like your terms and solve for x, and that will tell you how many games they won. Well, solve for x is how many games they lost. How many they won, you'll have to multiply that number by 2. Okay? Number 8. Here we have James has $5 more than Peter. Together they have $73. How much money does each person have? Okay, so our two people we're talking about right now are James and Peter. So James has $5 more than Peter. It doesn't tell us how much Peter has, so Peter has some value we don't know. James has $5 more than that, so you take what Peter has and add $5 to it. And together, meaning add, they have $73. So you have what James has plus what Peter has, and it's going to equal $73. Combine your like terms, use your opposite operations in order to solve for x. X will tell you what Peter has, and then you'll add 5 to it to find out what James has. And the last one I want to take a look at is the very last one, number 12. Bob and Sue each drove to work on Monday morning. Bob drove 25 miles more than twice the distance that Sue drove to get to work. The total distance they both traveled was 76 miles. How far did each person drive? So this one's a little more complicated, but it's the same idea. So we have Bob and Sue. Okay. Bob drove 25 miles more than twice the distance that Sue drove. Okay, so Bob has a lot going on with his, but Sue, it's all based off of what Sue did. We don't know what Sue did, so we call Sue's value X. Bob did 25 miles more, so we know that means plus 25, than twice the distance that Sue drove. So this is the distance that Sue drove, so twice the distance that Sue drove will be 2x. Okay, so 25 more than twice the distance that Sue drove, and Sue drove x. All right, together they drove 76 miles. So you take the distance that Bob drove plus the distance that Sue drove, and you're going to get a total distance of 76. Combine your like terms, use your opposite operations. When you find x, that's how far Sue drove. Take that x value, plug it in here, and solve for how much Bob drove. Let me know if you have any questions. See you in class.